to look at number 9 and 10 from worksheet number 7 here. Both vector addition problems, both with what we call funny angles here. Now, when I look at both 9 and 10, we can see these vector diagrams drawn correctly, right? When we're adding vectors together, 50, 75, 50, for instance, we have to draw those vectors drawn. What's the expression? 3 words? Head to tail. These are all drawn head to tail, right? The head of the 50 next to the tail of the 75. The head of the 75 next to the tail of the 50. And we can see the same thing in question number 10. They're drawn correctly. What we're missing in both of these vector diagrams is a resultant vector. The resultant vector goes where? From where to where? Somebody said it? From start to finish, yeah. So in this case, it goes right here from start to finish. Make sure you draw the arrow. Don't just draw the line, draw the arrow. Okay, that's important. And the same thing over here, we'll go from start to finish over here as well. That's the resultant vector. We'll call that R. That's the sum of all the vectors. We're adding these vectors together. We can't just say 50 plus 75 plus 50 is equal to 175. It's not, because we're adding them in different dimensions. We have to do something to find the value of that R. That's the resultant vector. That's the sum of those vectors. Now, what's the goal? What's the goal in all of these questions, including these two that you see up on the board? To get a right angle triangle. We don't have a right angle triangle in either one of these. We don't even have a triangle in either one of them, let alone a right angle triangle in these, right? So we got to get that. We got to get the right angle triangle by finding the x components and the y components of each vector, combining them, and then redrawing it into a right angle triangle. What do you see in question number 9 that's a little bit bothersome? Yeah, we get different directions, sure. But what do you see in question number 9 that we looked at yesterday in a couple of the questions that should draw a reaction from you? Martin? Well, you see 30 degrees. That's a funny angle, right? And what do we say when we see a funny angle? We don't like funny angles. Martin's getting mean here. Martin says, I hate funny angles. Somebody says, what do we do? Kill it. Martin says, I hate funny angles. No, I'm not that extreme. I just don't like funny angles, okay? So we get rid of it. We get rid of the funny angles. Let's deal with question number 9, and then we'll deal with question number 10 a little bit later on here. The funny angle that we have in question number 9 is 30 degrees, 50 meters at 30 degrees. So let me draw this over here, just off to the side. There's my 50 meters. Draw that. Like, some people just like to draw the line and not the arrow on the end of it. Draw the arrow on the end of it. Okay, that reminds you that it's going down and left. Now, I have an angle of 30 degrees labeled right here. If the angle is labeled right there, I've got to draw a triangle around it, and that triangle is going to go like this. This is my x component, this is my y component. Somebody may have tried to draw the triangle down here, but we're not going to do that because the angle wouldn't be inside the triangle then. So there it is. Remember that when you're doing this, that 75 meters is irrelevant right now for this. We're just trying to find the x and y component of 50. That 75 is independent of the 50 here. So, which side of the triangle is the x component there? It's next to the angle, right? So is the hypotenuse next to the angle. The other one that's next to the angle is the adjacent side, yeah. If we're looking for adjacent, we have hypotenuse, which is what we have here. Then we're going to use which trig function? Adjacent and hypotenuse. Cosine. Cosine 30 degrees is equal to adjacent over hypotenuse. And I think that works out to be 43.3 something, isn't it? What's the unrounded number there? 43.3102? 3103, I guess it would be, right? 4 or 5 decimal places is fine. I can live with 4, but don't round it to like 1 decimal place. Even if you round it to 1, you'll often get the right answer, but not always. If you round it to 4 or 5, you'll always get the right answer. 43.3103. Now the y component is the opposite side, so we're going to say sine 30 degrees is equal to opposite over 50, opposite over hypotenuse, and y is equal to 25 meters. Now I'm going to box that off. You guys remember why I said we box that off? Why I box it off at least? Just because that's what makes this question different. Right? Question number 9 is a little bit different than question number 7 that you can see right there. But the only difference between question 9 and question 7, other than numbers, the way we do it is this. So I just kind of box it off to remind me that the rest of the question is the same as the last group of questions that we were doing, right? Besides what's off on the side is exactly the same. Okay, now I'm going to go x components and I'm going to go y components. And we got to look at each vector now. Oh, by the way, some of you might like to do this. 25 meters and 43.3 meters. And then, well, just erase this 30 degrees and that angle from the family picture right there, and that's what we're left with, right? Now let's look at the x and y components of the 50 meters. What's the x component of that first vector, 50 meters? Nope. What's the x component of that 50, the first one? 0. 0. What's the y component of it? What's the y component of it? Negative 50, good. 0 for the x component because it's on the y-axis, negative 50 for the y component because it's on the y-axis going down. What's the x component of the 75? Blake? 75, good. It's positive? Yep. What about the y component of that 75? 0, good. What about the x component of the last vector, the 50-meter last vector that we erased from the picture? What's the x component of that one? Nope. Negative what? Negative 43. Negative 43.3 meters. And the y component of that one is negative 25. So now we add these up, the x's and the y's. 0 plus 75 subtract 43.3 gives me what? Uh, 75 minus 43 should be 43.3103, right? Gives me 31.6897. And this one's going to give me negative 75. What do I do with it now? Same as question number 7. What am I going to do with this now? Yeah, make a right angle triangle. That's 31. Where do I draw that vector for 31? To the right. How do you know it's to the right? Yeah, it's x component, and it's positive, so it's to the right. So we're going to say 31.6897. Where do I draw that 75? Down, like this, right? What's wrong? Somebody said no. What's wrong with that? Has to be head to tail. That's tail to tail. That doesn't work, okay? We have to draw it. Well, there's actually 2 options that I could draw it. This is one option, and this is correct. I'm not trying to trick you here. Where's the other option? How else could I have drawn this? I could have said 31 over this way and 75 right here, right? That's drawn head to tail, isn't it? That would be correct. You get a different angle, but that's because our reference point is different. Okay, it's like saying, I think yesterday we gave the example of me being 2 meters from this wall or 8 meters from that wall. It's both the same thing, just a different reference point, right? We'll draw it like this, the first way, since that's already labeled. My resultant vector is drawn from start to finish right here. And that looks a lot like the resultant vector that I already have drawn on my original diagram. Where am I going to label my angle? Position 1, 2, or 3? Position 2, yeah, always at the start of my vector diagram. R is going to be equal to the square root of 31.6897 squared plus 75 squared. We're going to say, let's do this on the calculator here. Second function, bracket, 31. Actually, let's just go. $31.6897 squared plus 75 squared, end that bracket, and we get a value of 81.4. We're actually going to round that to 2 digits, so it's 81 meters. So when we add all those vectors together, we get 81 meters. But we have to express it at an angle now. Theta is going to be equal to the inverse tan function of opposite over adjacent. What's the opposite side of the triangle here? Is it 31 or 75? 75 is the opposite side. 75 over the adjacent side Oh, you know what? I haven't done my little check sine 90 yet. Have I needed to do my check yet? Haven't dealt with any angles yet, right? Now I'm about to deal with the angle. For the first time I'm dealing with an angle today, I should check to make sure my calculator's in degree mode. Sure enough, it is. Okay, now I can do the inverse 10 of 75 over 31. $67 degrees. Is that good? Now, that's where I asked you to stop last night with question number 9. But I'm going to show you one more little thing. I've told you over the last day or two that ultimately we're going to need to express it relative to something, right? Because if you had have drawn it the other way, you would have drawn the y-axis, then the x-axis, you would have gotten an angle not of 67, you would have gotten an angle of 23. It's like saying 2 meters from that wall, 8 meters from that wall, right? You got to have that frame of reference. So I'm going to show you how to do that now with this question. We're going to say that this 67 degrees is measured. Let's draw little crosshairs here at the start of my diagram. You don't need to literally draw that unless you need to. It's okay to draw it, but if you can kind of picture it in your head, that's okay too. Now, we can see that this is west, this is east, this is north, and this is south. That angle is measured from which axis? From which axis? Is that angle measured from the north? Yep. Yes, it's measured from the east. Do you see that? Measured from the east. But it's not just east. It's from the east, but we're going south from the east, right? It's south and east, but it's measured south from the east. So we're going to say that this is 67 degrees south of east. South from east or south of east. How'd you draw this the other way? How'd you draw this like this, 75 and 31, and drawing your resultant vector this way, you would have gotten an angle of 23 degrees. And that would have been absolutely fine. But if you did, draw your little crosshairs here. Where am I measuring my angle from this time? This one's measured from the south. But yet I'm going east from the south. So this one would have been 23 degrees east of south. 67 south of east or 23 degrees east of south both mean exactly the same thing. That make sense? Yep.
What if you said like negative 23 south of east, negative 23?
Is that because you did inverse tan of negative 75 over 31?
No. I did the inverse tan of 31 over negative 75.
Oh. The inverse tan of 31 over 75. Oh, so did you draw it this way? Okay. If you do it this way, though, you should have got 23.
I did.
Oh, you did get 23.
Yeah,
Okay. Okay, so ask me again what you asked me.
Could I say negative 23 south?
No, you could not say negative 23 south of east. Okay, I could live with the negative, but it has to be east of south, not south of east. Okay, unless you calculated 67 degrees, then it would be south of east. Okay. All right, is that good? Write that down if you haven't already, and then we'll take a look at the next question, number 10. Let's look at number 10 now. Yeah, go ahead. Yeah. Let's look at number 10 now. This one is a little worse because it's two funny angles, right? Once again, though, every vector is independent of the other. So the fact that we have 5 meters at 60 degrees here, by the way, that would be 60 degrees east of north because it's measured from the north axis. And the fact that we have 30 degrees, this would be south of east because it's measured from the east axis. Those don't affect each other. The 10 meters completely independent of all those. So what I want to do is just take each of those vectors off to the side and find the x and y components of each of them. So here's my 5 meters first of all. 5.0 meters, and my angle right here is 60 degrees. Okay, let's label this as x, and let's label this as y. Draw your arrows, right? How do I know to draw my arrow up and then my other arrow to the right? Because the 5 meters is up and to the right. What's the x component here? Which side of the triangle? Is that opposite, adjacent, or hypotenuse? You guys know this. Is x opposite, adjacent, or hypotenuse? Opposite, yeah. Opposite, we have the hypotenuse, so we're going to say sine 60 degrees is equal to opposite over hypotenuse. I think that's 4.33? 4.330 what? And then the y component is going to be found using cosine. Okay, let's box this off. And let's replace this. Let's replace this with 4.3301. Let's replace this with, what is that, 2.5? And then let's Photoshop that family photo. Now it looks a little bit better, right? But we have another one to get rid of here too, right? This is like a really dysfunctional family here because we got another one that we want to Photoshop out here now. This one, let's take this one off to the side too. We got 10 meters at 30 degrees south of east. Here's our x component. Here's our y component. X this time, x is the opposite adjacent or hypotenuse this time. This is adjacent this time, so adjacent and hypotenuse goes with cosine. X is, what is that, 0.86602, is it? 8.86602, I think. And then the y component is going to be found by sine function. 10 sine 30 gives me 5.0. Box that off. Do our little thing with Photoshop. Okay, this is 8 whoops, this is wrong. I said 0.866. This should be 8.66, right? This is 5.0. This is 8.66. And then take our little airbrush here. There we go. There we go. Now it's easy, right? Well, not easy, but now we just do our x components and our y components of each of the vectors. What's the x component? Jesse, what's the x component of that first vector, that 10 meters? 10 meters? Almost. Yeah, we're going to make it negative 10 because it's to the left. Good. What's the y, Jesse, what's the y component of it? Yep, 0. Good. Lucas, what's the x component of the next one, the second 10-meter one? This one right here. Good. What's the y component of it? Good. Now the third vector, it was 5 meters. Rochelle, what's the x component of that one? Yep. And the y component of it is? Nope. That 5 meters went right and up, right? It's the 5 meters here. So we say the x component is 4.33. You did that correct. The y component is? Yeah, good. It's actually 2.5, but It's hard to read that. So, yeah. They're both positive because the x component is to the right and the y component is up. One more. We had 10 meters now. It was south of east, 30 degrees south of east. What's the x component of that one? Miguel, what's the x component of that last 10 meter one? Good. And the y component of that one is good. -5 because it's down. Good. Let's add those up. I'll pull out the calculator to add those up. Let's say -10 plus 4.3301 plus 8.6602 gives me a value of 2.9903. And this one's easy to do in our heads. -15, -12.5. Now we redraw it. 2.99. 12.5, by the way. At this point, I don't have to put in the negative because the arrow shows me the direction, right? Our resultant vector is right here. The resultant vector is the square root of 2.99 squared plus 12.5 squared, 12.9, 13. What's the opposite side here? Dedenik, what's the opposite side? Is it 2.99 or 12.5? Yep. Good. We already checked that we were in degree mode, so we don't need to do that again. Second function tan of 12.5 divided by 2.99. 77 degrees. Whoops, 77 degrees, what of what? Where is that angle measured from? Is it measured from the south? No. No, it's not measured from the south. Draw your little crosshairs here. That angle is not measured from the south. Look, it's not measured from the south. It's measured from the east. Okay, if it's measured from the east, but yet it's going south, it's measured south from east, or south of east. There's one more question up on the board here right now where we have to add 4 vectors together, 10 meters, 5 meters, 3 meters, and 5 more meters, except that last 5 meters is at a funny angle. The resultant vector would be drawn from start to finish. I want you to find the value of that resultant vector.